Hello, everybody. This is Professor Ma, and this is the sections on the chain rule shortcut. Uh, so what we're going to do in these sections is that we learn chain rule in last sections. Uh, in these sections, what we're going to do is just going to list. I'm going to list all the patterns of basically all the functions with the, the basic pattern of the chain rules for all the basic functions, depending on what type it is. There are basically three types: the power functions, the tricks functions chain rules, and the log exponential functions. Okay, so let's start out with the couple of examples. Here is the power functions chain rules and the trick function chain. Okay, so the power function chain rule over here. Oh, by the way, everywhere you see the letter U in this, pretty much in the entire PowerPoint, it means it's some sort of formula in the variable x. U is U of x. Okay? So if I'm dealing with some base formula U with a peak power, then the derivative is just that basically look like the chain the power rule. The power comes down and subtract one from the power. But chain rule says then you have to multiply the uh, derivative of the u, okay, at the end. Notice this is true for the. We always have the u, the presence of the u, in versus then times derivative of the derivative of u. Okay. So, for example, here's a function, and if I look at the functions, what type of function is it in the three different forms? The square function. I'm squaring some base, so it's u squared. Therefore, the derivative of u squared is take one power down. U is going to be, of course, u is going to be x cubed. This is going to be the u x cubed plus 1. So the derivative of these two comes down, subtract 1 from the power, and multiply by the derivative of u. Okay, in this case, x squared. And here, if I were to take these are three layer, I took the formula from just the one we just finished. I'm going to plug in the cosine. How do I take the derivative of these? Okay, now it's a cosine function. So the u in the formula will be all these things. So I'm taking the derivative of cosine of u, and it's going to be negative sine of u times the derivative. Okay, make sure you have these two things separate. Okay, and the first u is the same as original. In this case, it's going to be x squared, x cubed plus x squared. So that's going to be minus sine of the u times u prime. Okay, and now this, of course, derivative of this is like if I let me allow me to use the letter u again. This I'm looking at a derivative of u squared. So this is going to be 2u times u prime, and it's going to be 2 times x cubed. It's like the last one, exactly the same, times x squared. So that will be these portions, the derivative of that. That need to tack on to the minus sign to the front. So this is the expansion, expanded multiplication of the chain root of the derivative of the factors. Okay. So how many of such patterns are there? Basically, for each elementary functions, we have a chain. Okay. So if you recognize the formula is somebody to a power, then we will use the power rule. So fix the powers. If the formula is you're looking at a sine of something, then use the sine chain rule. If you look at a cosine of something, then you look at a cosine chain rule. And in particular, here's if you look at log of e to some power. Power could be some formula in x. Okay, some really cosine x, sine x, things like that. But the derivative will be e to the u prime, and then log of some formula will be, here's interesting, the u is in denominator and its derivative is in denominator. Okay, so these are the basic pattern of the chain rule. So, so here, if I look at this formula, this is to be in the way we're doing it, or this is a sign of some formula in x, sign of u, where u is x cubed. So then the derivative of that sine of u is x cubed will be cosine of u times derivative of the u. Okay, cosine u times derivative of the u, which is px squared. Again, notice we have u cosine u as the original u, the original x cubed, but then multiplied by its derivative, u and u prime. This is a power function. This is the third power of sine. So therefore, I will use the power function. So I will take the derivative of u to the third power. That'll be 3 comes down. Subtract 1 upon the power u squared times the derivative of the u. And then you have to say, oh, who's the u? U is sine of x. It's being cubed. So I have to take the derivative of sine of x, which is cosine. Here's an example of log, and then the derivative of log of u is, number is over here. Derivative of log of u is 1 over u, and then here is the derivative of the u, wherever the u is. So in this case, the u is played by that. So I take the derivative of, I have 1 over this u. Now I have to take the derivative of the u. And that, of course, is just a derivative of exponential functions. Now, this is exponential functions e to the 3x, and so so this is the form of e to the u. So it's going to be e to the u times u prime. And what's the u refers to? U is the 3x. In other words, this is the derivative of 3x over here at the end, which is going to be equal to 3. And times what? Original e to the unchanged e to the u, e to the 3x. E to the u, to the u times derivative of the exponent. Here then we have to use the chain rule plus, in this case, quotient rule. So basically, we have all the operations as multiply, subtract, divide in the composition, and we have all those rules figured out how do they operate under differentiations. Okay, and so this one we will need to apply quotient rule. Then as we work through the quotient rule, if I need to use some other things like chain rules, I have to use a chain rule. Here's a quotient rule. Okay, high d low and low d high over low squared, and then I have to take a derivative of these. And when I come to that individual problem is a chain rule e to the u power problem. Derivative of log of x is 1 over x, and derivative of u is the exponential chain rule, so it's going to be self times 2x. And that's the how we take recognize and using the chain rule to take derivative. Okay, it doesn't matter how many layers it is. You can just keep pushing until the last derivative in respect to x is taken, and no more derivative to be taken, and the process stops. That's what we call this the chain rule. Okay, so do the homework. Bye bye.